Hello. Alright, let's solve this question. It's a question involving Poisson distribution, right? People arrive randomly and independently, right, at the elevator in a block of flats at an average rate of 4 people every 5 minutes. Means that every 5 minutes, this is the interval. During this interval, the mean of this interval will be 4 people. So this is a Poisson distribution, right? Poisson distribution is talking about the mean in an interval, right? So we know that 5 minutes you have 4 people arrive by using the elevator, right? So if 10 minutes, this one will be double, right? Will become 8 people, right? This is the mean, right? Poisson doesn't mean that as long as 5 minutes, it must be 4 people arrive by using the elevator. No, this is a misconcept, okay? No, it's just a mean, right? Mean, average, okay? Usually, they will have 4 person, right? So, okay, you should understand Poisson distribution. So, A. So, find the probability that exactly 2 people arrive in 1 minute. Exactly 2 people arrive in 1 minute. Be careful with this question here because the mean will be different. So now they said that a rate of 4 people every 5 minutes, right? Now the interval now will be 1 minute. It's in a 1 minute, all right? In a 1 minute. So in a 1 minute period, right? 1 minute. The 5 become 1. Definitely 4 also become 4 divided by 5. The mean will become 0.8. 0.8. Do you know why? Because now 5 minutes you have 4 people. So we expected, okay, have 4. So now if 1 minute, we were expected with 4 over 5, right? 5 to 1 minute is divided by 5. Definitely 4 also divided by 5, alright? So we have the mean of 0.8 for a 1 minute interval, right? As the question clearly states that in a 1 minute period. So exactly 2, right? Exactly 2, a probability of exactly 2. So we can using formula as e to the power of negative lambda, right? Negative lambda 0.8. 0.8 to the power of 2 divided by 2 factorial, right? So this is the formula. So as we know that if Poisson distribution with the mean lambda, so the probability of x equals to r will be derived to be lambda e power negative lambda to the power r over r factorial, right? If 2, this will be 2, right? 2 factorial. So if you calculate this, okay, let's calculate. So which gives you the value of 0. In 4 decimal places, you will have 1438, right? 1438 as the probability for this problem. Right, okay, next from the same question. Okay, find the probability that nobody arrived in 15-second period, right? 15-second period. So you know that 1 minute, right? Just now you see 5 minutes, we consider 1 minute. Now 1 minute, which is actually 60 seconds, right? 1 minute have 60 seconds. So which have 0.8, right? 0.8. Now we have 15-second interval, right? 15 seconds. So 60 seconds is 0.8. So 15 seconds, right? So 60 to 15, you also divided by 4, right? Divided by 4. Because 4 times 15 seconds is 1 minute, right? So as this is divided, also have to divide it by 4. So you're getting 0.2. So for question B, the mean is changed to 0.2 because now it's for 15-second period, right? It's for 15-second period. This is Poisson. This is how we solve Poisson distribution. Probability involving Poisson distribution. So 15 seconds. So 0.2. Nobody arrived. Nobody. So during that 15 seconds, nobody in the elevator, right? So it's exponent power negative 0.2. 0.2 to the power of 0 over with 0 factorial, as this is 1, This so 1, so e power of negative 0.2. Alright, let's calculate, which we're giving you the value of in 4 decimal places, it will be 8187. Alright, okay, this is for part B. Alright, okay, let's look at part C. Right, okay, let's look at part C. The probability that at least one person arrive in the next t minutes, now is t minutes, so is 0.9. Right, okay, read carefully. The probability that at least one person, the probability that at least one person, as you know that x represents the number of person, right? So for 5 minutes, you have 4 person, right? You have 4 person. So means that now they said that x is represent the at least one person is arrived in the next t minutes is 0.9, right? Is 0.9. But because 1 minute, we have 0.8, right? 1 minute interval, we have 0.8. 405 is 0.8. So how about t minutes, right? In the next t minutes, so we have to multiply, as this is multiplied by t, right? 1 to t, so this is also 0.8 t. So the mean now should be distributed with 0.8 t, right? So they want to find the value of t. So at least 1 means 1 minus probability of x equals to 0, right? You should know that, because why? At least 1. What is mean by at least 1? 1, 2, 3, 4, so on and so far. But you must remember, there may be no one in the elevator, right? No one in the elevator. So that's why they want at least 1, right? So means at least 1 means everything here, right? At least 1, right? So it's the same as you take everything minus away px equals to 0, right? When you minus away px equals to 0, then this will be the probability of at least 1, right? So so px equals to 0 will be equals to 1 minus 0.9, 0.1, right? So again, apply the formula for Poisson, e power of negative lambda, lambda 0.8 t, lambda 0.8 t to the power of 0 divided by 0 factorial, right? So the formula, e power of negative lambda, this is your lambda now, and lambda to the power of 0 over 0 factorial, right, is equals to 0.1. Then we have exponential negative 0.8 t equals to 0.1, right? So same thing here, I'm going to solve this. So I'm going to put ln both sides, right? This exponential equation. So if once I put ln, negative 8t will be ln 0.1, right? Ln 0.1, and definitely this whole thing you can just bring it down, become negative 0.8t ln e, right? Ln e is here, so you bring forward here negative. So therefore, negative 0.8t is the same as ln 0.1. So finally, we can find the value of t. The value of t is you taking ln 0.1 divided by negative 0.8. Alright, okay, after calculate, you're taking ln 0.1 divided by negative 0.8. In 3 significant figure, you will have 2.88 minutes. Alright, so it means that the value of t will be 2.88 minutes. Right, that's all for this problem.